Okay, so my name's Richard Bishop. I work for Trust IV. We're a company that specialises in performance testing and general risk reduction in software projects. My background is as a performance tester, and I've been doing that since the late 90s, 1999, which sounds like an awful long time ago. Basically, the object of tonight is to try and introduce performance testing and performance testing concepts to people who may not be performance testers. I've been to a few of these events, and a lot of people are often asking lots of functional questions about Selenium and WebDriver and all those sort of things that I'm not very familiar with. So sometimes I feel like a duck out of water. Well, unfortunately, it's your turn to be ducks out of water, because I'm going to talk about performance testing. Hopefully some of you will have some experience of performance testing. Just a quick show of hands. How many people are there here who have done it or do it or manage it? Okay, there's a decent smattering, so that's good. I once did a presentation where I asked that question to well over 100 people, and 2 hands went up, and I thought, oh, this is going to be tough, but at least I've got a few kindred spirits in the audience tonight. First of all, I'm going to start off by talking about performance testing, why it's important, a little bit about test terminology, because it's a real minefield. You know, the difference between a soak test and a break test and a peak test and all these sort of things, they're all terms that are thrown around, and to be honest, I don't really think there's a hard and fast answer about actual definitions of these sort of terms, because they seem to be different at every customer I go and talk to. So what one person describes as one thing, someone else will describe as something else. So I think it's really just a warning. And basically, I'll try and talk you through the testing process. First of all, just to go back to basics, I'll just talk about testing in general. And the word cloud at the bottom is all the sort of stuff that you'll find on our website, the tester gathering website, forums discussing performance testing and so on. And there's probably plenty of tests there that you'll get involved with, whether or not you're involved in performance testing. But basically, just to go back to the basics of what testing is, it's doing something to work out how an application or process behaves. And that can be either at the component level or for a large application. And all of these different test phases that are all mentioned in there should all be part of the SDLC, which is the software development life cycle. Often there's things in there that are overlooked, or someone decides someone else will do it, or you'll do it later. And those are problems, but I'll come on to that. One of the problems with performance testing is it's often the thing that's tagged on at the end of all the other testing. So you've done your regression, you've done your failover, you've done your functional testing, user experience, all that sort of stuff. Everything's fine. Right, we've got 2 days left. We need to do the performance testing. And that's really where it all goes wrong, because through all those phases of testing, you really need to be considering performance. Because if you aren't, the difficulty is the performance problems, you'll find them right at the very end when it's too late to do anything about them. And that's why we all end up with rubbish websites and rubbish mobile apps and all those kind of things. So just going on, I'm just going to talk about a few definitions just really to set the context. So the first talk about unit testing, integration testing, and system testing. And in a way, I just describe those as different building blocks. So your unit testing is the first type of testing you can do, where you're testing an individual component of an application and just checking that it works and does its bit. And a lot of functional testing will be done at that level. Often performance testing isn't. And I would argue that it should be, because if all your individual components perform, plug them together and you've got a better chance of them performing. Similarly, with integration testing, you start taking multiple components and plugging them together and making sure you get the right results out of things. And again, performance testing is important there. And the last bit, system testing, which is where you're doing proper end-to-end testing and you're testing an entire application. That's traditionally where performance testers get involved. But I would argue that you potentially shouldn't. You should be thinking about that much earlier. Some of the problems that you get if you don't do that testing earlier is, as I've said, you've just not got enough time. And when you do find a performance-related problem, you've no time to do anything about it. this slide basically describes the difference, or some of the differences, between performance testing and functional testing. And I'll hold my hand up and say, there's plenty of people in this room who will just say every single one of those points is wrong, and they're probably right. Because if you look at functional testing, you say it's normally done first, and you're looking at functionality, you don't care about performance. Well, that's not strictly speaking true, because we've all gone to an application as a single user and tried something and it's been a bit sluggish. And you arguably don't need a performance tester to tell you that something doesn't perform. So it's sort of true and it's not. So a lot of these are real generalizations. Functional testing is also normally very comprehensive. You might be looking at all the different aspects of an application, and you try and go through all the different business processes that users may go through. And conversely, performance testing, what you tend to do is go for the low-hanging fruit. You've got a certain number of business processes that you believe are responsible for the bulk of the load on your application, and those are the ones that you really want to hammer with your performance test tool. Because we often use the 80-20 rule in performance testing, where 20% of the application is 80% of the load on your application is only on 20% of it. So if you're looking at a banking application, for example, logging on and checking your balance and logging out is probably what most people do most of the time. Bill payments is important, but it's not going to get hit to the same levels. So if you're going to prioritize which scripts you record, you do the ones that most people do first, and then time allowing, bearing in mind that as performance testers, we're usually only given a few days at the end, much to our disgust. That's one of the issues that we face. I'm not going to just read all the text. I've put some text on there so that these slides can be made available at the end and you can have a read of them, but I just thought I'd go through a few of those. And also, the thing I didn't mention is if any of you have any questions or observations, just shout out, so feel free to do it during the talk rather than just at the end. A couple of other things on there. The third point under functional and the third point under performance testing is about where you actually do your functional or performance testing. Functional testing is usually testing a user experience. So you need a browser or you need the client application to be installed and working fully so you can test it. With a performance test, you can run a successful performance test against a broken application, which sounds a little bit perverse, and I suppose it is. If, for example, somebody modifies your application code so the OK button is no longer there on your website, you could still run a performance test that tests the submission of whatever that OK button used to do, even though it's broken. So you can't do performance testing in isolation. You need to make sure that it is working functionally. And there are various performance testing techniques that test at the presentation layer rather than at the network layer, and it's good to have a mix of those two different test types when you're testing. The other thing you can do is run a functional test script at the same time as you're doing your performance tests, and that's a really good way of making sure things are actually working, because it can be hard to work out what's going on in a performance test. You've just got a whole load of network traffic going across, and if you're not capturing all the errors, you may not be aware that something is broken. So a functional test or even a manual test during the performance test can be useful. The next slide basically expands on the previous one, and again, these are generalizations. They're sort of true, but I can think of an example of at least every one of these that isn't true as well. So functional testing, typically testing the UI, but again, not always the case. Performance testing, I've said there, it doesn't test the application's front end. With an awful lot of performance test tools, that is the case, because you're sending network traffic across a network rather than simulating users actually clicking on buttons and so on. But there's lots and lots of grey areas in performance testing where that isn't the case. The other big thing I put there was one user and multiple users. There's lots of performance tests where you may only be simulating the actions of a single user or a single process, like batch performance testing. Or I've done lots of testing where you test an API which only ever has one connection to it, but a huge amount of transactions flowing through it, like payment systems, for example. So these are generalizations rather than hard facts, but I'm trying to give you a flavor of the difference of the two test techniques. So that takes us on to what the purpose of a performance test is. And it's a bit wordy, but basically just look at the bits that are in bold. And most of the slides that I've got, if there's something in bold, that's the important bit, and the rest is waffle, which I'm going to try and avoid. So yeah, basically it's quantifying the sort of risks that you may face before you actually put an application live, making sure the service level that you've agreed with your customer or potential customer, if it's say a retail site, you know, what their expectations are, and making sure that you can meet those with your application. One of the things that testing doesn't do is completely mitigate risk, but what it does is help identify potential problems and quantify those potential problems so that you can report back to someone who can do something about it, be it a developer or a manager of developers or whoever, or even just the marketing department. I did work a few years ago for an organisation where they sent out a mail shot on a regular basis. Every time the mail shot went out, it's a mass mail that went to thousands of members of this organisation, and they all clicked the link when it arrived. So they basically created a huge performance problem for themselves because their site was fine all month. The monthly mail shot went out, everybody clicked the email link and it fell over. So all they basically did to fix the problem was say, right, we'll mail out people with the surname A in the first 5 minutes of the hour and then the surname B in the last 5 minutes of the hour and so on, and basically just spread it all out, and the problem just went away. So you don't always need to spend a fortune scaling everything up and recoding everything and getting huge databases. You can sometimes just think your way around these things. One of the things that's on there, we talk about SLAs, so see whether or not the environment that you're going to deploy into will allow an application to meet whatever service levels have been agreed with a business unit. Those are important, but in a way you shouldn't conduct performance testing just to try and determine whether your application is production ready without having an idea of what those service levels should be. We get plenty of customers who come to us and ask for performance testing, and they just say, can you do us a performance test for 100 users? Well, the answer is always yes. But if you don't know what realistic expectations users will have for an application, you can't really give anyone a meaningful report. 60-second response time may be acceptable to some people, but unless you actually put it down in your requirements at the start, you can't adequately report as to whether a test was successful or not. Again, sort of focus on the bold bits on this one. Some of the things that you can get from performance testing is a better understanding of how application response times change as you add a number of users or as you increase the number of transactions flowing through a system. And users' transactions is often transposed in an awful lot of performance test reports and test plans that you see. And sometimes they're interchangeable and sometimes they are. I'll go into a bit more detail on that. But you may want to know how many users your system can handle. But without knowing what user behavior is going to be, it's almost impossible to say it'll do 100 users. I used to work at HBOS, and they had an internal intranet system, and I was asked to test it up to 70,000 user load because they said there's 70,000 employees, that's what you need to test it to. And it was really hard to say, well, no, 70,000 people aren't ever going to be on it at the same time, because they said, oh yeah, they are. Everyone has it set as their default browser, and when you open your browser, when you log in, it comes up and 70,000 is the peak. And the only way I could explain to the PM who was telling me to do this testing that was unrealistic was to basically say to everybody on the conference call, stand up and look around how many people that you can see, and it's one of these offices with cubicles all over, how many people have actually got their hands on keyboards? And the answer was, a handful. And it's very difficult sometimes to get the idea of users and the idea of transactions in someone's mind correctly. Because you can have a small number of users absolutely hammering away, doing a lot of work, And again, to use a banking analogy, a department of people keying in mortgage applications or insurance claims may well fit that bill. And then you've got people who've logged in, gone to make a cup of tea, come back, click something. 5 minutes later, they've stopped talking to their mate and they click something else. And you need to understand your user profiles as well as the number of users. So yeah, obviously the sort of load that might crash an application, you can learn that sort of thing. As well as how changes to either your hardware platform or your software platform can change performance. So it can be used obviously for performance tuning, optimization, those kind of things. This basically goes back to one of the slides from a little bit earlier. I'm probably banging on at this a bit, but basically when should you test? And the answer is always. So the minute you've got any code that you think you can performance test is when you should be starting, and you should be doing it literally all the way through the life cycle. One of the key reasons, these numbers are made up by the way on the left hand side, but one of the key reasons why you should look at performance at every phase is that as a project gets nearer to completion, or worse still after it's been released to an audience of users, all the way along that process, the cost of fixing defects is going up all the time. Right at the very start, you know, your little unit of code hasn't been coupled with others, and so if you make a change, it doesn't affect any other developers, for example. The further you get down to system testing and finally performance testing and then production, the more expensive it is to fix those defects. And of course, it's most expensive after it's crossed this line and gone into production. Yeah, somebody asked me last week, well, why is that always the case? And it's not, strictly speaking, always the case, because as people are doing more continuous integration and development, the cost of actually making these changes is coming down. But it's broadly speaking still true. The next bit is why performance matters, and this is a very old slide. I've not been using it since 1999, but I'm reliably informed that last century an 8-second response time was all right for a website. And then some statistics were published probably around 10 years ago now that said 4 seconds is what's acceptable. It's far from acceptable at the minute, and people are getting less and less tolerant of poor performance. There are some white papers which I'll make available. I'll as the slides come out, I'll send the links that I've got on my notes. But there were studies done, I think it was about 2008, that said, I think, or maybe later than that, hang on, let me look at the graph. It's probably about 2010. They said 1 second is the new 4 seconds, because a paper had been published saying 4 seconds was the point at which people switched off. That's way out of date now. Google have published statistics that say after 400 milliseconds, your average user who's clicked something and is waiting for something is already starting to show signs of irritation and being bored about how quickly something's coming back. And going on further from that, both Amazon and Google have done studies where they examine click rates on their pages based on the response time that page came back to a user. Amazon have noticed that 100 milliseconds slowdown reduces the number of people who click buy by 1%. And on a business of $100 billion a year, that's $1 billion that they're not getting if their site's slower. And they've measured that, and they know that that's fact. Google have similar stats for the rates at which people click on ads on pages, and it's literally milliseconds rather than seconds where they can measure those differences in user behavior. So I've probably banged on enough about performance testing. You may be coming around to thinking that you should perhaps be doing it. And if you are, these are the sort of objectives you have. That's not meant to be a pretty lilac colour. It's just meant to be in the background because the bold bits are the bit that count. But basically, you're looking to validate your application and make sure it performs or behaves as you would expect under load. You'll obviously have target response times that you want to hit, and testing can help you validate that. You want to identify the point at which the application breaks, whether it's a certain amount of user load or when your database gets to a certain size, all sorts of things like that. You want to primarily validate that your application will support the user load that you expect, as well as potential peak loads. And some of the things that people often don't do, they just do a test and say, all right, well, it passed. But tuning your application can be really important. As you go on a cloud platform, everyone, or a lot of people, have stopped worrying too much about whether they need more hardware to support an application, because they just throw more tin at it, which is really easy to do in a cloud environment. But obviously that's all cost. And if you can tune your application, you can get your costs down. I mentioned I/O and here, for example. One of the things that, for example, Amazon charge for, and Microsoft Azure, they charge for every call into the database on a cloud platform. And so if you've got an application that's calling something 10 times when it should just call it once and cache it, again, performance testing can help you identify that and tune those bottlenecks and potential increases in cost out of your system. So text has gone, a few pictures for a while, so hopefully that'll wake people up. Basically, yeah, I took these slides from somewhere else. I've had them on my hard drive for a long time, and I'm not quite sure what all the logos are. We had a debate in the office. We thought that this was a fan of some sort, and we weren't quite sure what they were, but we've established that they're probably firewalls, and that may be network. But basically, that's a typical application. You've got external and internal users. External users going through a cloud and into the network. Internal users just going through your internal network infrastructure. And an application that's a basic 3-tier application: web service, application servers, and database servers. And this basically shows that the sort of things that you can experience as a problem that you may identify through performance testing or doing it correctly. External users are particularly sensitive to network performance. So WAN sensitivity, you know, those large images that you've got on your website that probably shouldn't be there. It flushes those sort of problems out. For your internal users, you may pick up the transactions that are slower. They will be less affected by network speed, so they might give you an indication of the sort of things that are taking a long time in database or application servers. Network configurations is something you commonly find. I've done quite a lot of performance tests where you're running a test, you've got poor results, and when you actually look at it, you see your load balances have sent all the traffic to one server in a farm, and obviously that server's run hot and everything's slow, and the others are twiddling their thumbs effectively, if servers have thumbs. You'll obviously find things like capacity limits on web servers, slow methods in your applications, and so on, as well as issues in databases. So database contention obviously can be a problem, locking in the database, that sort of thing, bad SQL or indexes that are missing, those kind of things. So I've talked a lot about performance testing, and as I mentioned earlier, there are a lot of different definitions for types of performance test. So these are some of the terms that are bandied around a lot. And the next slides go into a little bit more detail. So I won't go into it in too much. But as I mentioned earlier, the definitions I tend to use are the ones on Wikipedia, which aren't bad. They're edited all the time by lots of people, so they may change. But I'm trying to sort of get people that I talk to use consistent terms for all the different types of test. So soak testing being a long one, for example, and then peak load and spike tests and break tests and all those kind of things. And a lot of the definitions are on there. But just to try and illustrate those types of test, I've drawn up some load profiles for the sort of tests that I'm typically asked to do. And I'll just briefly mention the reasons I might be asked to do those tests. So the first one, a normal load test, and this is common for most performance testing tools. You ramp up over a period of time. So the user load is on the blue line. Green is your average load that your system might be expected to achieve, and red is the peak load. So your load ramps up, it plateaus for a while, and then it goes down. And you typically do your performance reporting on that hour at steady load, so you can compare that with other tests. So that might be described as a baseline test, but you'll repeat these sort of tests a lot so that you can compare one test with another and make sure that your results are valid. Soak test is similar sort of thing, but it just runs for a long time, usually as long a time as you have. And a good example of this, I read a story recently about the Boeing Dreamliner aircraft, which you don't want to be on one when it's had its server switched on for more than about 240 days, because there's a piece of code in its brain, in its systems that manage its, I think it's its power distribution, and after it's been on for more than 240 days, it runs out of space to store the amount of time that it's been up and running, and it switches it off. And it switches off all power to every system on the aircraft, everything. It's not just your seat back entertainment, it's the engines, avionics, pilot's controls, the lot. So anyway, they've found this bug, fortunately, before it happened in real life, and Boeing apparently are putting a fix out. But until the fix is out, their standard IT fix for it is basically just switch it off and on once a week and it'll be fine. So, but it just goes to show that a soak test is potentially an important thing. The next two load profiles, the top left is a break test, where basically you ramp up a system until it breaks, and it can tell you some things. I'm not convinced it's always the best thing to do. Test environments are often smaller than your production environment, for example. It can give you some indication of how far you can push an application, though. And the bottom one is a spike test. There's lots of applications that bimble along at a nice steady level and then get a big peak in traffic. And that type of test profile is something that you may want to do. Retailers that advertise in big advertising breaks often like that sort of thing. You know, Black Friday sales that start at a certain time. Both Currys and Gain, for example, in the UK were down last Black Friday. I thought I had another slide on there with something else, but I'm sure it'll come up later. So you're going back into a little more detail. A baseline test, as I said, is the sort of test where you run one baseline and then compare it to another. So that could be a single user for a certain period of time to work out what your response time for a small user load will be, so you can make some assumptions and calculate the sort of number of users you'll need to run a realistic test. Or it could be a test at a normal load that you can compare with another test. This is a chart that I did with HP Load Runner, which is the test tool I tend to use, comparing the response time for exactly the same test against two different server configurations. So the one at the top is a single CPU with 4 gigabytes of RAM, and it was a Magento e-commerce application. And the one at the bottom is exactly the same scripts running with it's exactly the same user load, but with two cores. And obviously there's a dramatic improvement in response times. This is end-to-end response time for the whole script, but you know, we're looking at minutes at the top and seconds at the bottom. Load test is the classic performance test that I mentioned earlier, where you ramp up, run for a period of time, and then ramp down. Hopefully within that hour, you'll end up with some nice steady metrics that give you a feel for CPU usage, memory usage, all those kind of things that you want to report back to people on. This is one that's obviously gone a bit wrong because there's a spike in some of the counters part way through, but ideally you'd like lots and lots of straight lines, but obviously when you analyse your test results, you know that's the sort of thing you're looking for things that are of interest. That looks exactly like the previous slide, but basically that's showing a typical load profile, whereas you increase the number of users, the response times, after increasing slightly, something breaks and you get this knee bend in your charts. That was the picture I thought I was expecting a little earlier. It's the impact of unexpected load on an application. Kate Middleton's one of these people who has this effect on websites. She'll go out in a dress, someone takes a picture, and the manufacturer or the stockist of that dress, all of a sudden their website goes. So this is where a break test can be useful, to give people these theoretical limits that they can push their application to. And it's not just for fun. It is fun as a tester breaking an application and telling people where it went wrong. But it also helps you to get a profile of the sort of things to look for when an application is about to fail. So you'll have performance counters and you'll say, look, 2 minutes after this counter got to a certain level, your site broke. So you tell the people in ops, that's what to look for, because when that's getting close, you want to start spinning up some more web servers or putting some sort of queuing system in place to stop that traffic from bringing your site down. I'm flicking through these. A colleague of mine is going to do this presentation plus a bit of hands-on demo in June, and it's going to take about 4 hours. So I'm trying to get as much content in as I can. So feel free to ask questions either later or email them me, and I'll try and fill in any blanks. Soak test. This is the thing that Boeing should have done on their Dreamliner. It's basically a long-running test to identify problems that only appear over time, like memory leaks is a common one. That's the sort of load profile you might get on a daily basis. So you might want to run a test for 4 or 5 days, simulating user logins and log-offs. That's just an example of a long-running test. As I say, that will, as well as determining your acceptable performance under load, it'll also try and flush out long-running problems. The other thing you can do is you can have a baseline test that runs for an hour, and you could leave it running for 8 hours. You can still compare that first hour with all your other 1 hour tests, so you can double up a little bit when you do your results analysis. Isolation test, this is exactly the same as sort of manual and functional tests, where you've got a problem and you just keep repeating your tests with developers tweaking things or with DBAs changing things or whatever until you fix the problem or find the thing that's causing the problem. I think the key thing to remember here, it's exactly the same as functional testing. If you are going to change things between tests, only change one, because if you change 2 and that fixes it, you don't quite know which was the one that you changed and which was the right one to change. Configuration test, it's another term that you may come across, where basically it's a bit like that Magento test I did earlier with 1 core and 4 gig of RAM against 2 core and 4 gig of RAM. Determine the optimal performance of an application with different application configs. Sorry, I'll just go back. I'll leave it. That slide underneath it was HP Diagnostics, which is one of these performance application performance management tools. There's loads of them on the market, not just that. There's Dynatrace and App Dynamics and New Relic. They're all great tools and really good for getting an insight into how your application's performing when you're stressing it. There's a lot of detail there. I'm not going to read it because time is of the essence. One of the things that's worth also talking about is automated testing tools. You can performance test manually, but it's generally not particularly good. You can performance test on things like batch processes really quite easily without a test tool. But if you're going to run performance testing, you really need to be using a decent automation tool. I've worked in places where it's become so hard to test an application, we have actually gone ahead with manual tests. And you get a room full of people like this and give them all a screen and say, right, let's see if we can break it. But it's not good because it's not repeatable for a start. You don't know what each user is doing. And it's very difficult to report on performance because each user has their own perception about what works, what doesn't work. They can't quite remember whether they clicked A first or B first and those kind of things. So yeah, it's not good. So you want to automate it, and then you can just kick back like this chap in the slide, because that's obviously the way to do things. Okay, so yeah, as I've already said, it's very hard to performance test without proper automation. Obviously it relies on a large number of people to generate load, or a large number of PCs or whatever, and it's just not the way to do it. I've already mentioned that user responses are poor. You really need to be getting some decent metrics out of your application. So obviously my background is with HP LoadRunner, but all the general performance test tools that do record and replay can give you some decent stats about how an application performs. And And the other thing that's sort of key to remember is the cost of repeating a manual test twice is exactly, well, the second test is cost the same as the first test. Whereas if you do automate, after the first test, every test is effectively cheaper than the last because it's someone hitting the go button and pulling some stats back from that. So the next slides talk a little bit about how automated performance test tools work. And these again are some terms that may need a little bit of explanation. Basically, there are usually 4 components to a performance test tool. A script recorder, and in HP's case, this is called VUGen, which stands for Virtual User Generator. So it's the thing that records the interactions between a user and an application. You'll then have a thing which is either described as an injector or a load generator, depending on the tool and the company you work for. I've heard them used interchangeably. And that's effectively a load agent. So that's the piece of software that throws the load at the server that you're going to test under the instructions of something called the controller. Or in HP's parlance, it's called the controller. That also allows you to configure your test, and that's where you put in the parameters based around the number of users you want to throw at something, how much think time or pauses you want in between user actions. And with some test tools, even how quickly those users type and all those sort of things. And then analysis, performance monitor I've skipped. I shouldn't have done. The controller does that. That's the thing that manages the test, as well as give you real-time information about how a test is running. And analysis is the last one, which is where you look back through your results or compare multiple result sets to check on performance. The next slide is basically a picture which just gives you an idea of the sort of infrastructure you might need for a typical test. You don't need all of it for every test. This is one I used for a customer presentation, so I was trying to show where our kit was compared to theirs, which is why there's a Trust IV logo in the top corner. So that's basically me sitting on my laptop recording scripts against a customer's application. We'll then have servers which can be in the cloud or can be on a customer site, which is basically the controller. So you record your scripts, upload them to the controller and tell it to manage your test for you. I'll go in a bit more detail about that. But the other thing I'm trying to show here is that you can run tests over firewalls. So you may want your load generators outside the firewall to simulate real users coming in to a customer's infrastructure. Or alternatively, you might want load generators. Sorry, I've just realized I'm standing in front of that, so half of you probably have only seen half of the slides. Yeah, the load generators can also be inside a customer organization. So this diagram is just to show you your test tool can be configured in lots of different ways, and how you configure it and where you place things can have a real impact on your performance test. So it's something that you need to consider at your test planning stage. These are the fans are back, but basically this shows how a script recorder works. So typically you've got your traffic coming from your users through the network into your test application, and what a script recorder typically does is record that traffic and convert it into scripts, which is what the little white icons are up here at the top. So you've got those scripts which mimic user actions, and you can then use those in your tests. The next screen is a screenshot of HP LoadRunner's script recorder, VUGen, and it's typical to an awful lot of test tools. So down the left-hand side, you've got things like parameters, which are things like usernames and passwords. You don't want to simulate the same user logging in all the time. So those are typically text files with lists of users and passwords, for example, or other test data that you need to feed into a script. You can have function libraries, all the sort of functions you might write for error checking and all those kind of things are all in there. And then your right-hand side, you've got the script itself, where you've got things like transaction names and transaction timers and think times and all those kind of things. There's usually a record button at the top. Usually looks like a red circle regardless of your test tool, so you click that and that records your traffic. And a play button so you can simulate a single user and make sure your script works. Once you've done that, you'll then want to upload that into your test tool to build a scenario of multiple scripts to simulate your load. When we're talking about load, the load generators, which are these boxes on the left-hand side, they effectively take the scripts and pretend to be large numbers of users hitting your application. In applications such as Longrunning, you typically have a list of these machines. These can be cloud machines, they can be local machines, they can be remote. You can put them all over the place, really. But then the placing of them is pretty critical. You'll get radically different results running tests over the internet against running them locally. And so it makes sense to try and run your simulated users over as close to production, a realistic network, so that you get an idea of what performance is going to be like. If you don't do that, one of the things that you'll have, if you run all your performance tests at land speed, you'll get an idea your application performs. If you then slow all those users down by running them over the internet or in real life, you may find your application doesn't perform because each user is consuming more resources by holding connections open for longer and so on. I think I've already talked about this, so I'll skip the slide, but you can read it because it explains the last one rather well, probably better than I did. Yeah, the test controller is, as I said, it's like the orchestrator that manages your performance test. It also gives you real-time stats as to how your test is running whilst it's running. So you'll have charts and graphs that basically show you got to a certain user load and that's where you had a problem. And if you're monitoring a test as it runs, that can be a really useful tool to be able to ring up a DBA and say, I'm running a test and I can see from the performance stats that are coming back from this particular server that it's running hot. Can you look at it? And often it's easier for them to find a fault whilst that fault is actually there than it is to ring them up and say, I ran a test last night and it failed, something went wrong about midnight, not quite sure when, can you look into it? And asking them to delve through logs doesn't make you particularly popular, so it's often better to try and monitor in real time if you can. Yeah, performance monitoring, it was on an earlier slide and I think I skipped it actually, but that's pretty crucial as well. As I've said, if you're monitoring your application infrastructure, you get a real feel for what's going well and what isn't, so it's crucial to do that in real time if you can. There are lots of tools that takes performance stats like perfmon stats and allow you to import them into your analysis tool after a test. But it's not really a substitute for doing it in real time if you can. Yeah, this is an example of the analysis screen from Longrunning, which basically shows this is monitoring Unix performance on a particular box. But you can obviously see that must be the ramp up happening because obviously one of the counters is getting busier. But you're basically looking for, if you're running multiple baseline tests, you want them all to look similar because any differences in the patterns that you see in your analysis window are obviously things you need to be looking into. Yeah, these slides might be in the wrong order, so that's something I need to look into. But yeah, the analysis module basically takes the details of the scripts and all the performance stats and the response times, all those kind of things, and then presents them in a way that is potentially useful to you or your customer if you're doing this for somebody else. That looks remarkably like the previous one, but it's actually the same test that we were looking at earlier. So the one where I had two charts for Magento application response times. This is the same. So we've got 1 core and 4 gig against 2 core and 4 gig, and you can basically see the number of hits per second that the servers were serving out during those tests. You've obviously got minimums and averages, and these are things that are really nice and easy to compare if you paste those things into a report. But it's also important that if you're running a test, say for an hour at a certain load, that you compare the same hour in one test with the same hour in another, so you're not comparing a bit of the ramp up when a machine wasn't that busy with another test where at that same time a machine was under heavy load. Once you've done your analysis, that's exactly the same screen as on the or in the test tool as the previous slide. You'll get a chart like that. This is an HTML report that LoadRunner does, but most test tools do something similar. Once you've done that, you can then report out into Excel, which can be useful. I mean, send the reports out, by all means, that's fine. But a lot of people will want to try and get the data so that other people can look at it and compare, whatever they're interested in. So, lots of tools allow you to export things into Excel or other analysis tools. And I think that's pretty much it. It was a bit lightning, so I hope that was okay. But yeah, if you want to have a go with LoadRunner, that's the one I'm most familiar with. Most test tools allow you to download trial versions, but the latest version of LoadRunner allows you to run a performance test up to 50 users, and it's free as well. So it's a perpetual license for 50 users if you need it. And you can do quite a lot with 50 users. So the link at the top is our website where you can click on downloads. I think the LoadRunner one you're after is at the bottom of that page, but I might just bring that up at the end and just point it out to you. But if you download it, you install it on a machine, you'll then get, if you do the full install, you'll get each of the modules, so your machine can be a load generator and a controller, and do the results analysis if you want to. There's a few links there to blogs. There's obviously the Trust IV blog, which talks incessantly about performance testing. Then there's other people's blogs that I read a lot, so those are probably worth mentioning, including, I think the bottom one, Develop Senses, Michael Bolton's, and I know he spoke here 2 talks ago, so if he didn't put that up then there it is again. You can also get in touch with either Trust IV or me through Twitter, and my number's at the bottom. And as I think we said, these slides will be made available. So I don't know whether anyone has any questions or whether they want to ask me anything. Feel free if you do, or come and find me afterwards.